students, welcome back to the Beyond the Horizon Astronomy program. Today we are presenting you with the lesson number 6th, in which we are giving you the history part of the Greek astronomers, the last portion. We have already discussed about the many astronomers in the Greek ancient astronomers, like Aristotle and Aristarchus. All these people we have told about you. Now, in this last part, this 6th part, we are actually presenting 3 important astronomers of the ancient Greek astronomy. Among that, number 1 is Eratosthenes. Number 2 is Hipparchus. And third is Ptolemy, the great astronomer. Why it is called as a great astronomer? Because one of his book written in 13 volumes, that book existed in the European astronomic world for near about 1500 years. That means for 1500 years, whatever the Ptolemy has written in the book called Mathematical Syntaxis, that book was actually lost at the time of ruin of Roman Empire. Everybody knows that after the Greeks' hierarchy, Roman Empire came to existence. But that Roman Empire later completely ruined. After that ruin of the Roman Empire, the book which is called Mathematical Syntaxis was lost forever. But luckily, the Egypt was conquered by the Arabian marauders. These people have actually responsible for the destruction of the library, the great library of Alexandria. The library which was destroyed, after that more than 10,000 papyrus rolls containing the knowledge from all over the world was actually destroyed by the fire. The entire Greek astronomy history actually collected by the Ptolemy was later found out some Arabians, Arab astronomers. They got that books. They have only translated that books into Arabic and given a name in the Arabic. Name is Al-Majest. That means the great work. That Al-Majest only afterwards translated into Latin, took to the Europe. And the content of that book, actually it is the universe, about the universe. It has content of the book is actually about the geocentric universe. That ideology, that geocentric universe ideology, actually if we go back to the Greek astronomer Aristarchus, his ideas about the heliocentric universe never accepted by Greek people. But it was actually the geocentric universe idea which is supported by the Ptolemy and the Aristotle, which only reflected in that mathematical syntaxis or the Arabic book Al-Majesty. Majority of the Europeans up to 15th century, the content of that astronomical ideas was accepted by the Europeans. So when the Arab people has found out the mathematical syntaxis and then it is retrieved by those people and translated into their own language. That is called Al-Majest. Al-Majest, in the meaning of the Al-Majest is the greatest. So that book only actually prevailed in the Europe up to 15th century. There was no going back because the content of the book was actually accepted by the most important religious people of those period in Europe. That's why it is accepted by the Europeans up to 15th century. In the 16th century, when Copernicus began to inquire about and began to understand the geocentric ideas of the universe, then only he learned so many things from his predecessors. Like all over the world, there are a lot of people, thus Arabic people and other knowledge they accumulated in the Alexandrian library. It was all examined by the Copernicus. And the ideas he has calculated, even from the Greek astronomers like Aristarchus, only he accepted his idea and he brought forward the idea of heliocentric model of the universe. Until that period, prevailing knowledge was about the mathematical syntaxis or Almagest. So, here in this episode, we are giving the last historians of the Greek astronomy, that is the three people, Eratosthenes, and the second Hipparchus, and the last one was Ptolemy. Today, we are presenting you the sixth part of the Beyond the Horizon. In that, we are bringing you the history of Greek astronomers, the last part. Number one is Eratosthenes, then comes Hipparchus, and last Claudius Ptolemy. Eratosthenes lived between BC 276 and BC 194. Was a Greek mathematician and a geographer, an astronomer and a musical theoretician who lived in Cyrene. That city is in modern Libya. He was a poet also, and because of his poetical status, then Pharaoh of Egypt, Ptolemy III Oergate, ruler of the Egypt, appointed him as the chief librarian of the great library of Alexandria. Library of Alexandria during his period collected books containing various branches of knowledge from all over the world and kept in this library in thousands of papyrus rolls. In the papyrus rolls only on those days the knowledge were inscripted, which these rolls after the fall of Roman Empire was completely gutted by fire by marauders from Arabia in 3rd century AD. Eratosthenes around BC 255 invented the armillary sphere, which is an instrument which used to understand the celestial motions of the planets. Not only that, he was the first astronomer to calculate the tilt of the earth axis accurately, that we know nowadays, that is 23.5 degrees. Here is the Eratosthenes painting with his disciple. He is very famous for one of the great experiments he has conducted during his period to find out the earth's circumference. And that experiment is considered most simple experiment out of 10 even during the modern science history. You may be knowing about the meridian. What is meridian? Already we have explained to you one of previous episodes. Meridian is the great circle on the globe that is crossing through south and north poles, and the prime meridian is called important meridian, that is actually passing through the famous observatory at London, Greenwich Observatory. And he selected two cities. The method how he conducted the experiment, I am going to tell you. He selected two cities in the same meridian. One is at north, and that city is called Alexandria, his own place. And the other is Siena. That city is now called Aswan, in the south of the meridian. He obtained the distance between these two cities from the Bematists. And who are the Bematists? They were the surveyors accompanied great Alexander during his invasion of East. These Bematists measured the distance covered by Alexander with the help of an odometer. The odometer is an instrument used by those days by the marching army to find out the distance covered by them. So after obtaining this distance from Alexandria and Siena, he noticed one thing: the summer solstice that falls on June 23 every year. On that day, sunrise falls in Alexandria vertically in a well. But on the same day, in the southern city Siena, it falls making an angle of 7-degree inclination. This 7-degree is the 50th part of the full circle of the globe. Globe is 360 degrees. By multiplying the distance between the Alexandria and Siena by 50, that distance was 5,000 stadia. By multiplying this 5,000 stadia by 50, he got the measurement of distance, complete meridian's distance. That means the circular distance of the globe. That means circumference of the earth. That is, he got 250,000 stadia. And what is stadia? Stadia is the measurement on those days used by the Greek to distance. Somehow he got that circumference of the earth 39,984 kilometers. That is very near to the modern measurement, 40,000 kilometers. Here, in this picture, you can see how Eratosthenes measured the meridian's total distance. You can see there is a globe here in this picture, and the point by the black dot shown here, the point shown here is the center of the earth. It is imagined as the center of the earth. And here the Alexandria is shown. This is Alexandria. The other is at Siena. That is called Aswan. The measurement between these two cities are measured by the Bematist, that they have got 5,000 stadia. That is equivalent to 1/50th of a circle. How this is found him out? Here you can see, on summer solstice of June 23, sun's parallel rays are falling in the well correctly in parallel. But at the same time, in CNA, the same parallel rays on the same day is falling in the CNA as well by making an angle of 7 degree, inclined angle, English angle. You can see it from here. This is Alexandria and here is CNA. The distance between 5,000 stadia. So this 7 degree angle from the length of the pole and its shadow, that is 7 degrees equal to 1/5th of a circle. 1/5 of the circle is, if it is 5,000 stadia, then one circle will be 50 into 5,000 stadia, that will be equivalent to 250,000 stadia. That is equivalent to 40,000 kilometers. That is the most simplest form of experiment carried out by Eratosthenes. That's why it is considered as the one among the best simple experiment out of 10 even now. We have completed Eratosthenes. Now we are talking about the Hipparchus. Hipparchus lived during BC 190 and 120. He was also a great astronomer. But here works, nothing is available now. He was born in Nicaea. This Nicaea city is now in Turkey. Work was not preserved except the details available in the work of the later astronomer Claudius Ptolemy. The Ptolemaios wrote 13-volume books, collected the material of his predecessors in astronomical details, and that book is called Mathematical Syntaxis. This book later known as Almagest in Arab language. Why it is in Arab language? The entire knowledge which was created by the Greek astronomers was lost after the fall of Roman Empire. So, the later period, Arab people when actually came to Egypt, they only actually these books and the knowledge what the Greek astronomers made or could not preserved. Actually, Arab were only the people who has actually found it out and then they have translated into Arab language. Hipparchus made observations from the observatory built in Rhodes Island. He used many datas and Metonic cycle, Ansaro cycle, and sexagesimal system of arithmetic from Babylonian sources. Contents of 14 books said to be written by him through the comments of later astronomer Aratus. Other important contributions of Hipparchus was revealed by Ptolemy in his Almagest. Hipparchus was the first astronomer to use the trigonometrical table for computing the eccentricity of the orbits of Sun and Moon. He used various instruments such as astrolabe, armillary sphere, gnomon, etc. During BC 135, he was able to measure the geographical latitude and time by observing fixed stars. Compiled first star catalogue containing 1050 stars and made a celestial globe his own, on which he marked the constellations which was previously found out by the Babylonians. He was the first astronomer ranked the apparent magnitude of fixed naked eye stars according to their luminosity on a numerical scale from 1 brightest to 6th faintest. The ranking was such. That means he has given the brightest star as the, according to its luminosity, he has marked it as magnitude as 1. And then the faintest magnitude star he has given the number 6. It is in the ascending order. This system was made more precise and scientific by another scientist. He was very recently in 1856, he was a scientist astronomer in British India. He was stationed at Madras State. His name was N.R. Pogson. He placed the magnitude on a logarithmic scale, making the magnitude 1 star 100 times better than or brighter than magnitude 6. Thus, each magnitude is logarithm of 500, or in another way you can say 2.512 times brighter than the next faintest magnitude. 1 to 6, then total magnitude will be 100 times. It is actually, even now it is called as a scientific method to find out the magnitude of the naked eye stars. Another important discovery made by Hipparchus was the precession of equinox during 127 BC. Here you can see one top which is gyrating. Imagine it is a globe and center pole is called an axis, and then this globe, while rotating, the axis will be making a circle in the sky like this. This kind of motion is called gyration. This is what Mr. Hipparchus, how he has found out. Let us see it. According to the Ptolemy has only found out this, the complete inventions of Hipparchus, and put in his own book. Hipparchus measured the longitude of a star, that star called Pica, that is the constellation Virginis, Alpha Virginis star. And the other star is star Regulus in the constellation of Leo, that is called Alpha Leo. He has observed that these stars has moved 2 degrees relative to autumnal equinox. What is autumnal equinox and what is vernal equinox? This thing we already learned. You may be remembering that. He also compared the length of the tropical year and the sidereal year and found there is a discrepancy in the length. He concluded that the equinoxes were moving through zodiac circle and the rate of movement is not less than 1 degree in a century. That means 100 years. That is the reason here it is shown, the gyration of a globe, of a top, that axis will be making a complete circle on the sky. When it is making a circle in the sky, every degree of the sky, it will take 72 years. Actually, it was found out by Hipparchus 100 years, but at present it is only 72 years. Precession, what is precession? Precession is a change in the orientation of the rotating axis of a rotating body, as in the case of a top, as we just now told. Here it is shown as a top only. At the same time, you just see this bottom picture. It is shown as a globe itself and its axis. If this globe also rotating, then this axis of the globe will be making a large circle in the sky. In our case, it is the Earth. Earth is having an axis rotating about within 24 hours once. While rotating, it also revolves around the sun in a year. During this revolution, axis of the Earth draws a circle in the sky. Time taken to move 1 degree in the sky is 72 years. That is the latest figure. At the time of Hipparchus, he found it is 1 century. That means 100 years. But now it is very correctly measured, and we understood that it is 72 years for 1 degree. And to complete one circle by the axis of our Earth, it will take 25,920 years. May I come to Claudius Ptolemy now, who lived in Roman part of the Egypt during 100 and 170 AD. He lived in Alexandria. He born at Hermios. His famous work, Mathematical Syntaxis, as we already told you, later known as Almagest in Arab, is the only surviving ancient treatise on astronomy. The question is whether, you may ask whether it is the correct astronomy or not. That we will discuss later. After Hipparchus, Ptolemy derived his geometrical model that not only reflected the arrangement of planets and stars, but could be used for calculation of celestial motion. He was much interested to find out the timing and movement of the planets because he was an astrologer too. Astrologer who is actually placed with the future of the people. He has to find out the motion of the planets, correctly for the prediction of the future of the people. Ptolemy presented the astronomical tables which could be used to compute the future or past position of the planets. Almagest also contained a star catalogue, which we have already told. It was actually prepared by Hipparchus. It lists near about 48 constellations of northern hemisphere and not of the whole sky. This is actually Ptolemy's universe. For over 1,000 years, Almagest was authoritative text for astronomy across the Europe, Middle East and North Africa. It was preserved like many Greek works in Arabic manuscript. Because of its reputation, it was widely sought after and then translated into Latin twice in 12th century. His planetary models, like those of majority of Greek astronomers, were geocentric, except Aristarchus' model that was heliocentric, and universally accepted until its reappearance of heliocentric model of the universe during 16th century scientific revolution. What is the geocentric model? You can see it from this diagram. Suppose this is Earth. On those days, Greek astronomers, except Aristarchus, thought that the Earth is the center of the universe and all other planets seen above the head is actually including sun, moon. What are the planets considered? Here it is lunar, that means moon. The second is Mercury, because the moon is very near to Earth. Second is Mercury, third is Venus, fourth is Sun, and then next is Mars, and then Jupiter, and then Saturn. Beyond the Saturn, the astronomers were knowing about other planets like Uranus or Neptune. These were found out afterwards, after the age of the telescopes. So, this is the Ptolemy's universe, including Sun, and all these planets are going around the Earth. And the funny thing is, some of these planets are making some retrograde motions also. And this model was accepted universally until the reappearance of the heliocentric model of universe during 16th century scientific revolution. The handy tables are set of tables together with the canon. We collected all the data needed to compute the position of moon, sun and planets, their rising, setting of stars, eclipses of sun and moon, making it useful for astronomers as well as astrologers. These tables were known through the Theon of Alexandria, a later mathematician. Planetary hypothesis is a cosmological work probably last written by Ptolemy in 2 books dealing with the structure of the universe and laws that govern celestial motion. Thus, He went beyond the mathematical model of Almagest to present a physical realization of universe as net of spheres in which he used epicycles. Remember the epicycles to compute the dimensions of the universe. We will examine what is epicycles. He estimated the sun was at an average distance of 1210 earth radius. Now it is actually 23,450 earth radius. While distance of stars he estimated 20,000 radius of earth. Ptolemy's second most well-known work is Guide to Drawing Earth, that is geography, a book on how to draw maps using geographical coordinates for the part of Roman world. He was an astrologer too and wrote an astrological treatise in 4 parts called Tetrabiblos. Now we will see what is epicycle and all. Here we have seen this is the model of the universe of the Ptolemy. In center is the earth, because in earth only human being is there. So they gave most important to earth only. And all other planets and other things are moving around there, including moon, Mercury, Venus, Sun, then Mars and Jupiter and Saturn. And beyond that is the realm of stars. You can see it from here, the realm of stars. So, with this kind of model of the universe, he could not actually describe why certain planets are making retrograde motions in the sky. Even now you can see it. A man who observes the sky during evenings or early morning, you can see the Venus, planet Venus in the early morning along with the sun. The same time, Venus you can see in the evening also. Those days, people were thinking all the planets have a godly capacity. They are all gods. So they have their own way to think how to travel in the universe. So, Venus was considered as 2 stars. One is early morning star with the sun, and the same star you can see in the evening also at the western horizon. So, how to solve this problem? Why it is happening in twice? Ptolemy could not clearly given the correct answer for this. But he was very clever. He has found out reason for that. He used the epicycles. What is epicycle? This is epicycle. Suppose this is earth. And around the earth, planets is moving its own circle. That circle is actually moving on the another circle. That is called epicycle. This is called epicycle. So how they say epicycle's movement or the planet's movement in retrograde motion is described. Let us see here. This planet, while moving from here to here, it is going like this, arrow mark is given. Same planet, if it is came like this on the epicycle, then it will be moving, shown as moving like this. So sometimes the planet goes towards the eastern side, and sometimes it goes to western side. This is what Ptolemy has described the retrograde motion. But completely Ptolemy, whatever the trouble he had taken, he could not actually describe it, why the retrograde motion is happening with the help of even the epicycles and the other type of movement. Thousands of epicycles he has to make to describe it. Even then he has failed in that perspective. This is what Ptolemy's world of universe. Though actually what we will think about now, if somebody takes the earth, is moving around the sun, the entire picture is different. Simply imagine the earth is moving around the sun, then one can easily find out, because each planet is moving in the sky in its own speed. We can take an example of Mars. Mars is actually moving at less speed than Earth. Here we can tell it in an example. What is an example? Two cars are moving in the same direction in different speeds. Suppose one car is moving very fast and the other near the next track, the other car is moving in a less speed, then the driver in the first car, he will see that the other car is moving backwards. If the other car, then second track, if it is moving fast, then driver will be thinking that his own car will be moving backwards, the other car is moving fast. This is just kind of a car race which is happening in the sky. It's a very simple. Only thing, you have to imagine that the earth is moving around the sun. Because of the difference of speeds of planets in the sky, we feel that these planets are making retrograde motions and forward motions sometime.